Okay. Am I audible and visible, guys?
Yes, ma'am.
Is someone sharing screen? Because I can't see my own video. So this is the first day of your Infosys crash course, okay? Is the screen visible?
Yes, ma'am.
So as you guys requested, right, you were telling that maybe your exam would be faster than 25 days, before 25 days. So we have to complete the sessions before that only. That's why we have extended like our timeline, whatever I gave you, right? So today only we are going to do day one and day two both. As you can see, I have prepared two PDFs for day one and day two. So today only we are going to cover. And one request, guys, since there are a lot of people, right? If you have any doubts, just note them somewhere. Don't interrupt between while I am teaching, because maybe if you have some kind of doubt, maybe I'll come to that while teaching only after 5 minutes. Okay, after 5 minutes, automatically maybe your doubt would be solved. So try to avoid asking in between. After the class is over, or after like this one PDF is over, you can ask, or after one particular problem is over, I'll ask you. Whatever doubts you have, you can write in the chat instead. Okay, I'll read through and explain. Okay, so without further delay, let's start because we have less time. Okay. So first topic we are starting is arrays, right? So basic introduction I will give. After that we'll jump to coding. So array is a linear data structure that we know, which is used to store multiple elements of the same data type in a contiguous memory location. Okay, multiple elements we are storing in a contiguous means one after other in the same memory location. Each element in the array is identified by an index starting from 0. So array elements we know that index starts from 0 and ends at n minus 1. N is the length of the array. Okay, so like if there are 10 elements, there would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, till 9 index same has. So you can see there is like 4 elements, 10, 20, 30, 40. This is the way you write an array. And okay, someone is asking that if I am going to show code in Java, C++, and Python. Yes, I am going to show. So index is starting from 0. 0th index has 10, first index has 20, second index has 30, third index has 40. Okay. So the array stores elements in contiguous block of memory. That means if the first element is at 200, the second element would be 204. If integer is of 4 bytes. Third element would be at 208. Index 0 refers to the first element. Index I can be accessed directly using ARR of I. This is common syntax. I hope you all know. If you don't know, you will know now. This direct access makes arrays obviously efficient. That is why we use array, because of its indexing property.
Excuse me, ma'am.
Yes.
Your voice is not clear.
Is my voice not clear, guys?
Ma'am, your voice is flickering out.
Is it clear now? Is it clear now, guys? You can turn on the mic and say, because there are a lot of chats I cannot see. Wait, let me disconnect my mic. Now is it clear? Can you hear me now properly? Is it proper?
Ma'am, your
Yes,
voice
ma'am.
is not clear.
It's clear, right?
No, ma'am.
Okay. No, ma'am, or yes, ma'am? Someone is saying yes, someone is saying no.
No, ma'am.
No, ma'am.
Okay. Is it clear now?
Yes, ma'am.
Clear, right? I can proceed then.
Yes, ma'am.
Okay, fine. Might have been some issue. So, I hope you have read through while I was explaining. Uh, just normal definition of the array only I went through. So, what the key properties of array is? Array has fixed size, okay? Defined at initialization. Okay, doubts you can ask in the chat, but if voice is not clear or screen is not visible, that you can turn on the mic and say only, okay? Because otherwise I'll not read the chat and proceed, right? You will miss out things. Stores homogeneous data of same type, supports direct access using index, like indexing property, that is what we use in array. And contiguous means I explained that 200 index, then 204 index, then 208 index, because integer has 4 bytes. Okay. Accessing any element requires O of 1 time complexity, that means constant time complexity, because directly we can access it using ARR of I, like that, indexing. And traversing entire array requires O of n as my time complexity, because a for loop, you will see right now, a for loop we use. Traversal means visiting every element of the array sequentially. How can you sequentially visit? By using this for loop. For int I equals to 0, I less than ARR of dot length. Why not I less than equals to? Because array element starts from 0th index and ends at n minus 1. Okay. Then you just print the array elements if you want to print, or if you want to do a sum, you will do sum equals to sum plus n. Okay. Loop starts from 0, continues till ARR dot length minus 1. Each iteration accesses only one element. All elements are processed exactly once. Why only once? Because in the first iteration, that is 0th iteration, 0th element would be accessed. Then 1th element would be accessed. Then second element would be accessed, like that. Okay, so this is how I've explained it in 0th index 5, 1th index 10, 2th index 50. These are all basic things. While coding, it will be better. But this is just a revision. Okay, O of n is the time complexity. Now, how to find the minimum and maximum in a array, smallest or largest element in an array. You will define int min equals to ARR of 0. Everything would be defined as the first element of the array. ARR of 0 means the first element or the element at the 0th index. This is my minimum. This is my maximum. How do I find the min max? I will iterate through my array, but you will see that the iteration begins from the I equals to 1 index, not I equals to 0 index. Why? Because I equals to 0 index we have already considered when I have assigned my minimum and maximum here, right? As a default value. This is not my minimum maximum. This is a default value. And this I am doing without sorting. Because if I sorted it, I would have taken n log n time. But I am doing it in one pass, right? So minimum equals to map.min of min comma ARR of I. Means every iteration it will go through, it will compare this ARR 0 which I had stored in min and my ARR of I. That means the current element. If my current element is greater than my minimum ARR 0, then minimum would get updated. And if my current element, that is ARR1, is greater than my max, then my max would get updated. So this is the check that internally happens. This you can do is using for loop as well. Just like I say, if it's greater, then max would be updated. If it's lesser, then min would be updated. Okay. So we initialized min and max, started my traversal from 1, then compared each element and updated the values accordingly. This is the dry run. If 4, 2, 9, 1, 5 are the elements, initially 4 is the element and the minimum and maximum we have stored as 4 and 4. There is no need to update. We have not compared till now. Then comes the index 1, 2. Now we are comparing if 2 is less than 4. Yes, 2 is less than 4. So update my min. Min is now 2 and max is again 4 because 2 is not greater than 4. Then comes my second position, like second index element, that is 9. Is 9 less than 4? No. So there is no update for my minimum update. But 9 is greater than 4. So that's why the max update happens and maximum is now 9. Then comes my element 1 from here. You see third index. Is 1 less than 4? Yes. So min gets updated and I store 1 over here in min, but max is the same. Then comes element 5. Is 5 less than 4? No. So 1 remains the same as minimum and max, it is not greater than 9. So obviously max is also not updated. So ultimately 1 and 9 are your min and max elements. Okay. Time complexity here will be O of n because it is in one pass. One traversal is required, no need to sort the array, so it is optimized. This is an example of optimization using tracking variables. Okay. Now, running sum. What is running sum? Running sum is the process of calculating total sum while traversing the array. This running sum we will see in the day 2 PDF. Okay. This running sum we are also going to do using the prefix sum method rather than your normal sum which you do. This is your running sum for int each value in my ARR. This is a for each loop. You will store sum equals to 0 first. This is your initialization. Now each value in my array I am going to take. For int num of ARR, sum plus equals to num. That means each time I am accessing one element, I am storing inside my sum. Okay. So by the time my whole iteration completes of my full array, if there are 10 elements, 10 times this would happen and 10 times inside my sum, I'll store all the 10 elements, like I'll add up all the 10 elements. So after everything is done, after I've calculated this, my whole sum of all elements inside my array would be my answer. But this is normal sum method. This we can also do using prefix. Because ultimately what is happening, prefix only, right? This we'll see in the day 2 PDF. Maybe you will not understand right now. Okay. Detailed dry run also you can see 1, 2, 3, 4 are the elements. Now, here only you will get the idea of prefix. Whenever you see this previous, right? This is the prefix sum. Current prefix is 0. New means 0 plus 1 gives 1. Now what happens? This was my previous sum, right? So this becomes my prefix. Prefix means the current element. Before that, whatever elements have occurred, right? Previous to that, whatever elements have occurred, that is your prefix sum. The sum of those previous elements equals to prefix sum. So now previous has become 1, current element is 2, 2 plus 1 is 3. Again, we'll go back to my previous. Previous becomes that new previous sum we calculated 3 and current element is also 3. 3 plus 3 is 6. Okay. And then previous becomes 6, last element is 4, 4 plus 6 is 10. Time complexity is n. Sum is computed on the fly means like in one loop only. Each iteration sum is calculated. There is no need for extra space. Only one variable is required. A variable is not usually considered as any extra space, right? Usually if you take one array or hash table, things like this is considered as extra space. Why is it not considered a variable? Why not it is considered as extra space? Because variable takes a very negligible amount of space. This concept is extended to prefix sum, as I said, in the next topic. Okay, now what are the patterns in array we will see? As I said, running sum, prefix sum, maintaining totals, these we are going to see. Then minimum, maximum value, how to track them, these we are going to see. Single pass optimization, how to do everything in one loop, that is O of n time complexity we will see. Now sometimes you would say that there is one easier approach, right? But that easier approach takes O of n squared time complexity. Here we are going to learn how to optimize things further, because whenever you go to the interview, your interviewer will ask you that how can I optimize this further? I don't want you to use sorting. I don't want it in O of n squared time complexity. I want you to optimize it further. I want you to do it in one pass. That's what we are going to see in each problem. Each problem I am going to show you 3 types of method to solve it. Maybe 3, maybe 2, maybe 4. How many ways we can solve in each problem we are going to see. Why? Because in one problem, we are going to actually see 3 problems. So if you solve one problem, one code, that doesn't mean you're solving one code. I'm going to show you 3 ways to solve one coding problem. So that means you're solving 3 problems. Okay. Always check if the array is empty before accessing ARR of 0. Correct initialization is critical. Avoid any redundant traversals. That means again and again, don't traverse one array. That means O of n squared. And in terms of optimizing brute force solutions, this we are going to see. So quick summary before going to the coding questions. Array stores elements in contiguous memory location for faster access. Traversal is the most fundamental operation. Problems like min, max, sum can be solved in one pass. And understanding these basics is essential for topics like sliding window. We are going to do, actually in this PDF only, we are going to do sliding window. Prefix sum, dynamic programming without array you cannot do, right? That's why I put these things. Now, before I go to the coding problems, I want to tell you something. I think you have, since you have purchased this course, you have already seen what our schedule is going to be, right? Array, prefix sum, then sliding window, like this we are going to go. Then later on hash tables, you're going to see in day 6 or 7 maybe. But today only we are going to use hash table. Now, why I am telling you this? If I am teaching you hash table in basics, why are we using hash table today itself? Because if you don't practically solve a problem using these data structures, you will not understand them later. Like hash table is what? I will show you later on, the basics of that. But how are we using the hash table? That is what is important, and that you're going to understand it while I'm explaining you the topic itself. How this is going to help you? Let's say if your exam is in the next week, right? Some way, God forbid it's next week, but if it's on next week, then by the time your exam arrives, you will have the grip of these data structures rather than waiting for day 7. That is how I have curated these questions. Okay, now let me just see the chat once. There are so many people. Yes, some practice questions will be provided. Yes. Should we code side by side? No, please do not code side by side. Why I am telling you? I have given everything in this PDF. These things you don't have to put, like don't have to make another notes. You can practice some, like take this PDF as a note. Why I'm telling you don't code side by side? Because you'll miss certain points I am saying if you're trying to code side by side. This is only 2 hours of lecture. So keep your VS Code aside from you. Don't open VS Code. Just look into the Zoom screen. If you want, you can take a copy to note down what I am saying. If there is something other than the PDF that I am saying, note that down in a copy because that is faster. But don't code somewhere else, okay? Just try to focus on the screen itself because whatever I'm going to say, it's there on the screen only. Just for the 2 hours, try to stay with me. After that, you do all your coding of this you want to practice, just do after that. Okay. Recording will be available after this. No, 3 questions which we will solve is not enough to learn array. Of course, nothing is enough to learn because you have to keep learning. Learning never ends, okay? Till today, I am learning things. I am working as an ST, still I am learning things. Everything is new to me. Every day you will come up with new things in your life. But whatever I am going to teach you in this session is going to be helpful for you to clear your concepts. Maybe something which you have not learned previously, you will learn today in this class. That is what it is all about. You have to practice more, obviously. After I teach in this class, you have to practice further. Only with these 2 hours, you are not going to be like, you're going to be better, but you're not going to be like the best person in the world, right? What is the expected test date? That I cannot say, but previously from what I have seen, after the last date of registration, after 13 days, the exam was held. So I'm expecting something like that, but if before that exam happens, then I don't know. Resume shortlisting is happening right now. Yes, mainly teaching will be done in Java as it was defined in the course itself, but I am going to explain you the Python and C++ codes as well. Okay, now let's not waste time, right? I'll come back to your questions later on. Now let's see the first problem. Given an array of integers nums and given an array of integers nums and an integer target, return indices of two numbers such that they add up to the target. We'll see what this question is saying. You may assume that each input would have exactly one solution and you may not use the same element twice. Okay, so that means every problem will have at least one solution. That means you cannot say no solution exists. They have already told that solution exists no matter what. And we cannot use the same element twice. You can return the answer in any order. What is the question saying? Array of integer nums and integer target. This is my array, nums of 2, 7, 11, 15. And this is my target, 2 sum. What is this question saying? 2 elements should add up to my target. You can see that 2 and 7 is adding up to my target 9. Only one solution would be there. They have already mentioned in the question. So because nums of 0 plus nums of 1, that means 2 and 7 equal to 9, we return 0 and 1 as our answer in the form of array. In the second example also, let's see 3, 2, 4, target is 6. Can we achieve 6? How? 2 and 4 if you add up, you will get 6. How are we getting it? Index number 1, 2 is there, index number 2, 4 is there, add them up, you will get 6. Then again target is 6, 3, 3, 0 and 1 is there. So what is this saying? You may not use the same element twice, but that doesn't mean that if duplicate elements are present, you cannot use them. Duplicates are present, I can use them. But what it is saying is I cannot return 0, 0. That means I cannot return 3 plus 3, the 0th index 3 twice. Okay. Some constraints are given that we don't have to see. Only one valid answer is there. Now, this is the main point why I am saying that I am going to show you 3 ways or 4 ways or whatever ways to do one problem. Can you come up with an algorithm that is less than O of n squared time complexity? O of n squared is the easiest way to do this. How? Let's see. This is the brute force solution. So this is my array. I have taken an array of size 5. 16, 8, 23, 4, 15. Indexes are 0, 1, 2, 3, 4. This is my index. I hope you can see my cursor. Target is 19. That means using 2 elements, I want to achieve the target 19. I want to achieve the sum 19. Element A plus element B should give me 19. The indexes of element A and B I want to return as my answer. If I was using that O of n square approach, how would my problem be solved? I will take 16 as first iteration. That means 2 loops I will require. Outer loop will contain this 16. Then inner loop will contain 8, 23, 4, 15. Okay. This is going to take you n squared time complexity. But still we'll see, because even the brute force solution you can do in your Infosys coding assessment. But when you go to the interviewer, then the interviewer might ask you to optimize it. So, even your test cases might not pass because of optimization constraints as well. That is why optimization techniques are better for you to solve. 16 plus 8 we'll do first. 24. Is it equal to 19? No. 16 plus 23, this element. Is it equal to 19? No. 16 plus 4 equals to 20. Is it 19? No. 16 plus 15 equals to 31. Is it 19? No. So using 16, I could not find my target 19. Now I'll come to 8. That means my outer loop has incremented. My ith loop, that is my outer loop, has gone to 1 now. And my inner loop is again starting from I plus 1, that is 23. Ith loop for I equals to 0, it will start like that, and inner loop will start as for j equals to I plus 1. Okay. 8 plus 23, 31, not equals to 19. Again 8 plus 4, not equals to 19. 8 plus 53, not equals to 19. Okay. Again, my outer loop has incremented because we could not find the answer. Now my outer loop is at 23. 23 plus 4 is 27, not my answer. 23 plus 15 is 38, not my answer. Answer is 19, right? So we have not got 19 here. Again, my outer loop has incremented and it has come to 4. 4 plus 15, is it 19? Yes. So we have got our answer. Now, since we have got our answer, we are going to return the indices of these two. 4 is 3 and 15 is 4. So that means I am returning my I and my jth index. I comma j index would be your answer and you will return it in the form of array. But what if my array is very large? This I have only taken for 5. So n squared time complexity, still it might run. But what if I have n equals to 10? How will it run? So there might be some constraints, right? That would be many combinations. That is not possible. Ideally, n squared time complexity is very bad. Next approach we can do using sorting. If we sort, my time complexity would be n log n, because the best sort you can do is either quick or merge sort, which takes n log n. So n log n time complexity now I have come down to. N log n is better than n squared. 16, 4, I have taken a larger array now to show you. N equals to 8. 16, 4, 23, 8, 15, 42, 1, 2. These are your indexes above, right? In blue, these are indexes. After sorting the array, it becomes 1, 2, 4, 8, 15, 16, 23, and 42. Now, after sorting, let's see how are we going to solve it. As I said, in this video, you are going to see sliding window as well. Sliding window topic is actually coming later on. But still, I am taking these kind of problems so that you become familiar with these problems, so that you don't face any problem during your exam if it comes sooner. So this is my sorted array. Now please follow the color combinations to see what I am trying to do. I have taken 2 pointers. First pointer, that is the left pointer, is at 1. That means my 0th index. And the second pointer, that is my right pointer, is at last index, which is 42. This is a sliding window. This is a window which you can slide. This window is starting from my 0th index and ending at my last index. How does this help me? I can do things in one pass. That is how it would help me. Now let's add up one, and also it would take a lesser time compared to which you were taking previously, because now there are 2 pointers instead of 1 pointer. These 2 pointers you can move simultaneously. That is how it is going to help. Again, I'll add up these 2 pointers. 1 plus 42 is 43. Now we are not only checking if 43 is equal to 19, but if we are also checking if 43 is greater than 19 or lesser than 19. Why? Because if my 43 is greater than 19, as you can see, that means I need a value which is smaller than 43. Currently, my pointer was at 42, and this is an array sorted in ascending order from lowest to greatest. If my sum is coming greater than my target, that means I need to reduce my sum. I need to reduce my sum. How to reduce my sum? Not moving the left pointer, because if you move the left pointer, then your sum increases. See, from 1 to 2 it will become. 1 will be incremented to 2. I don't want that. I want to reduce my sum. That means I will move my right pointer towards left. So that's why I did right minus minus. Okay. The moment you do right minus minus, follow the colors. Now it will come to this 23. The next line is in blue. That's why I've marked it in blue only. 23 is my right now. Left is still in one only. So my window has reduced now. My window previously was from 1 to 42, but now my window is from 1 to 23. Again add 1 and 23, it gives me 24. 24 is again greater than 19, so again I will reduce my sum. Move my right pointer towards the left, decrement my right pointer. What is this right pointer? Right pointer is your index. Using this right and left, you are going to access your elements. ARR of left, ARR of right. Okay. Now again decrement this right pointer and right comes to 16 now. So come to the green line. Left is still 1. 1 plus 16 is 17. Now see, 17 is less than 19. That means I need to increment my sum. I was previously decrementing my sum, but now 17 is less than 19. 19 is my target. I need to increment my sum now. That means I will move my left pointer towards the right. So previously my left was at 1, but now I have moved it to 2. Now my window is between 2 and 16. Okay. Now add up 2 and 16. 2 and 16 is giving me 18. Again 18 is less than 19. So what we will do? We will move the left pointer again because we need to increment the sum. Left pointer was at 2. You are moving it again. You are getting 4. So left is now at 4 and right is now at 16. 4 plus 16 gives me 20. 20 is greater than 19. What happens when 20 is greater than 19? That means I need to reduce my sum because it is greater than 19. When you are reducing sum, what happens? You move your right pointer towards the left now. You need to reduce the sum. So right minus minus again. Right was at 16. Now you have come to 15. So now the window is between 4, 8 and 15. Left is 4, right is 15. Calculate the sum. 4 plus 15 is 19. Then you will see that 19 equal to 19. So I have got my target. The moment I have got my target, 4 and 15, I will search this 4 and 15. Now look up 4 and 15 in the original array. The moment I have found these two values, 4 and 15 add up to 19, I look them up in my original array, not the sorted array. I look them up in this array, 16, 4, 23. This is my original array. The moment I look up 4 and 15 in original array, I get index 1 and 4. These are the index values, 1 and 4. So that's why answer is 1 and 4. The time complexity would be n log n due to sorting. Quick sort, merge sort is the fastest sort. Okay. But can we optimize it further without sorting? Absolutely. Now comes the sigma. Without sorting, how to do? Hash maps. As I said in the first session only, you are going to learn a lot of things. Now, if I ask you something, let's say someone didn't know sliding window before to this class. Today you have learned, right, what is sliding window. Without a separate session, you have learned what is sliding window. That's why I'm saying the definitions don't matter. You need to do it by problem solving. The moment you come to this problem solving, you'll learn what is sliding window. You don't need to learn the definitions that there is one pointer left, there is one pointer right, this is the length of my window. No. Now hash map. First, before I start explaining, let me tell you what a hash map is. In a hash map, there are two things. One is a key, another one is a value. Let's say this is not a hash map, but a hash table. This is a hash table having two columns. One is key, another one is value. So every time we store in this, there is two things I am taking in this table. One is integer, another one is index. What is the property of a hash map? I can search everything very easily in a hash map. Okay. In one pass, I can search everything in a hash map. Searching is the easiest thing hash map provides. That's why I've taken hash map here. You see the time complexity later on. In this integer, I am going to store certain things, and in this index, I am going to store certain things. Now, if I ask you what is the value of 23 present, you look up in the hash map, search wherever 23 is, that takes constant in one time, one pass. In this 23 points to 2. So that means the value of my 23 would be 2. Now you have learned what a hash map is. Easy, right? It's a table. Simple thing. A table with 2 columns. Now again, I have taken this array. Now a different approach I am going to show you using hash maps. That's why I'm telling using one problem you can solve, you can learn 3 problems. That is 3 ways of solving. That's what's important because you're not going to mug up the problems. Target is 19. What is happening here? 19 minus 16 equals to 3. What is this? Complement. 19 is my target and 16 is my current element. The complement of 16 with respect to 19 is 3, right? 19 minus 3. Target minus current element gives me 3. Now what am I going to do? I have created this table. Consider this table as empty. This table doesn't have any values, okay? Consider it as empty. No values are there. Now this 3 I am going to search in my table. Is it present in the table? No. 3 is not present in the table. If 3 is not present, I will put 16, 0. That means if my complement of that current element is not yet present in my table, I am going to put my current element and its index value in my hash map. We'll see the syntax. Current element is 16 and its corresponding value will contain its index. Why? We'll see later. Then comes the next element. See, next element at index 1 is 4. So 19 minus 4 gives me 15. Is 15 present in the table? No. So that means I am going to put 4 and its index in my table. 4, I am putting it in the integer and index is 1. It was at the first index. Next element is 23. 19 minus 23 gives me minus 4. Not 4, okay? Minus 4. Is minus 4 present in the table? No. So again, I am going to put my current element and its index value 23 and 2 in my table. Let's come to the next element, 8. 8 is at index 3. 19 minus 8 is 11. Is 11 present in the table? No. So put, where is it? I have not put 8, right? Sorry, I have put 11 here. This won't be 11. This would be 8. Consider it as 8, okay? 8 and 3. 8 and 3. Please make a note wherever you're making a note or in a notepad, write down. This would be 8 and this would be 3 as it is, not 11. 8 and 3. Okay. Now, again, since we did not find the complement, come to the next element, 15. 15 is the next element at index 4. 19 minus 15 gives me 4. Now, why were we putting all these values in the hash table? We were searching, right? This complement, search it in the hash table. Once you have searched it, you will find that 4 is already present in the search table. In this hash table, 4 is already present. So, what will be my answer? At first index, it is present, right? So, what is my answer? Answer would be index of my complement from hash table. That is 1. 4 was my complement and the corresponding index of 4 from my hash table. From your hash table you retrieve because that is the easiest. Index of complement from hash table and my current iteration index, that is I. What is my current iteration index? 15 value we are taking currently and the index of 15 is 4. That means 15 plus 4 gives me 19, right? 4's index I am retrieving from hash table and 15's index currently I am iterating, so I is already there in the for loop. So I am taking I from there, a current iteration. So that gives me 1, 4. As you can see, the time complexity has reduced often and space complexity is also often because hash map takes n spaces. Okay. Why time complexity is often? Because everything happens in one pass, right? Only one for loop you need for iteration. For looking up, you don't need anything else. Now let's come to the coding part. I hope everything is clear now, all the basic things. Let's see the code. Now, one thing I want to point out, right? Coding is not the important part in DSA. DSA understanding is the important part because Infosys is not an easy exam, right? We know the package. So lead code level problems would come in Infosys. Okay, so you need to understand the problems rather than mugging them up. Okay, in semesters mugging up will do, but here the mugging up will not do. So we have a method public int toSum. Int array means it returns an array. Why array? Because see 1, 4 I am returning in the form of array only, right? So answer would be in the form of array. That's what was written in the question. This is my method which accepts my int nums. This is my array and my target. So it is accepting this. It is accepting this array and the target. Okay, int nums and targets. Then what did I do? I am obviously the best approach only I am going to show you in code using hash map. One table I have created, right? This table how to create. Map of integer because first column was integer and next column was index. Both of them are of type integer, right? So map of integer map equals to new hash map. This is how you declare a hash map. This is a syntax. I cannot explain you further why you declare it in this way, because using new you allocate the memory. This is a hash map. Using a constructor, this is created. A map object is created of type hash map. Okay. If I were to explain, this is how I would explain. But this is simple English, just like we are communicating. I have no reason to explain you why I am doing these things, but that is how English is spoken. Similarly, that is how this is written. This hash map is my constructor and map is the object of type hash map. Object means in this case variable. Using this MP, we are going to retrieve call some methods. So this MP object will call some methods and new is used to allocate memory. Okay, for this hash map. Now we are going to iterate. That O of n time complexity you saw, right? That is for this for loop. I start from my array index 0 till nums.length I++ for each iteration. Nums.length means nums.length -1 till my last index. And I am going to calculate my complement. That is what we were doing over here. 19 minus 16. 16 was my current element. 19 minus 16 gives me the complement. Okay. If map dot contains my complement, I have calculated the complement here. Target is 19 minus nums of I means my current element 16. If map dot contains key is the method we use to search in this table. I was telling, right? Is it present in the table? No. Then put 16, 0. Put, we'll see how to put. But searching is done using this. This one line will search in your hash map. That is why hash map is the best data structure for any kind of problem solving. If map dot contains key of the complement, if my map already has my complement present, then what am I going to do? Return new int. What is this new int doing? Like defining a new array. Okay, we are defining a new array and returning what? Map dot get complement. I'll tell you what it is. And I. What did I write over here? Answer is my index of complement from hash table. That means 4 I was getting, right? 4 plus 15. So 4's index is 1. How am I getting? Using this map dot get complement. The moment you give get, you will get these values, the index values, the get. That means the key. Key is my integer column. Value is my index column. Okay. Each key will have a value. The value of my key 4 is 1. Okay. So after seeing that the complement exists in the table already, I am going to return map.get complement, comma I. As I said, the current iteration index. That means my 15's index I. So I was my current index, so I have returned it. Now this was if I got the complement. What if I didn't get the complement? I need to construct my table, right? So if this 3 is not present, then put 16, 0. That is what I do. So if my map doesn't contain the complement, I will not go inside this if, right? So I will come directly here. mp.put nums of I. mp.put nums of I, comma I. What is this dot put? I am filling my table. Put nums of I. Nums of I means 16, comma I means 0. So I am putting 16 and 0 over here. Okay. This will automatically create your table. This happens for the entire duration of your for loop. After it is done, we will return. After it is done, we have already returned the formulated answer. Okay. 1,4, which was your answer. That has been already returned from here, from directly from this line. But then what is this return new int brackets? This means if we don't get the answer, we are going to return an empty array. But that was not in the question. It was mentioned that it will always return a value. But since integer we are defining, we have to return something. It is not void. That's why we have returned an empty array. Okay. Quickly, let's see the C++ and Python code. Again, same vector. That means an array. To some vector int, it is accepting an array and a target value. Then we are initializing the map. This is the syntax for initializing the map int np. Then let's iterate through my array from 0 to nums.size and calculate the complement. Complement is target minus nums of I, as I said. Then mp.find complement. This is my find method like I was doing in Java. Similarly, this is finding in my hash table. If my find not equals to mp.end, that means I have not reached the end of the table, right? I have found something before reaching the end of the table. If my value is found in the table, then return my mp.complements value, which we saw, comma, ith index. If my value is not present, then I'll put it in my map. How to put it? Map of nums of I, just like array. In my nums of ith index of my map, put I there, right? That is what 16, 0, right? In my map of 16th index, put 0. That's what we did over here, okay? Else, if nothing is found, return an empty array. Similarly, for Python, Python is even easier. Define the method is there, right? Nums and target is passed in the method, and there is one empty map we have declared, simple declaration. Then run the for loop from 0 to my length minus 1, and the complement is calculated, target minus nums of I. If complement in map, simple English, if my complement is present in map, then return map of that complement's value, comma, ith index. Else, if it is not present in my map, it will not go inside this for loop. It will not go inside this if condition. Come out of that if condition and map of nums of I inside that nums of I, that is 16, put 0. This happens for the entire array. If no solution is found, then return empty array. Okay. Next problem. Let me see the chat once. Recording is available. Yes. Yes, PDF you are going to get. Don't focus on development right now because there is no time for you to do a better resume anymore. Like after you get shortlisted for the interview, you can do the better resume part. But now you have to focus on coding because if you don't get selected in the exam, then there is no point of development for Infosys. Okay. Guys, please don't ask questions related to this form fill up, Aadhaar card and all that. I don't know, and honestly, if I knew, I would have helped you. I'm sorry. But right now we need to focus on the class, right? Because less time is there. Resume shortlisting happens, yes. That is where most candidates get rejected. I am hoping that's because of CGPA, not any other criteria. Can we focus on one language? No, we cannot. Other students are also waiting, right? Otherwise, people will start telling why I'm not explaining. I have explained you the pseudocode, right? The proper explanation. Then I have explained you the coding. What's the problem? Resume shortlisting is there. Okay, fine. Now let's do the second question. Best time to buy and sell stock. Okay, now this is a question I had faced during my own interview. It was during interview I was asked to do this problem. That's why I chose this problem. So you are given an array prices where prices I is the price of a given stock, buying and selling stocks. So when can you maximize your profit? How can you maximize your profit? If you buy it at a less price and sell it at a high price. Simple. So prices index is given, prices array is given. This price is 715364. This is your array. In this array, all the 7156, these values are of the stock prices. That means on my first day the price is 7, second day the price is 1, third day 5, fourth day 3, fifth day price is 6, then sixth day price is 4. That is how the values are given. I want to maximize my profit by choosing a single day. Only one day I can choose to buy my stock and choose a different day in the future to sell the stock. That means I cannot sell before buying, right? That's not practically possible. And in the problem also, it's not possible. I have to first buy, then sell the stock. Why I am telling this line, you'll come to know. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay. So if no profit is achieved, return 0. Why I told this line that I cannot sell before buying? I am not crazy. I have told this because I took interview of multiple candidates based on this problem, and multiple candidates, what they did for this problem is they found the maximum element, that is 7, found the minimum element, that is 1, did 7 minus 1, and 6 is my maximum profit. I'm telling you, this is what maximum students did, not one student. So that's what your thought goes, first of all, that I will find the maximum minimum, then the problem is solved. No, that's not how it's solved. Output is 5. How? If you buy on day 2, that is at price 1, and sell it at 6, then you will get the maximum profit. Buying on day 2 and selling on day 1 is not allowed, obviously, because you must buy before you sell. Similarly, then another array is there. I'm not 76431. See, the profit is 0. Why? Because 7 is the highest element, then 6, 4, 3, 2, 1. It is sorted in descending order. How can you get any profit? Each and every day has higher price than its after day, right? The preceding days have higher price than the succeeding days. So no transactions are done, so max profit is 0. Okay. Now look for solution. As I said, like just finding the min and max won't work. We can't sell before buying. How is it calculated? 715364. 7, that means my profit is 0. I have just bought it. Okay. On the first day, day 1, my price was 7. I have just bought my stock. I have not sold it. So my profit is 0. The next day, my price is 1. So what will I do? I will buy the stock, right? So if I buy on 7, I don't have any profit. 15364. No matter the day I sell, I don't get any profit because 7th is the highest element. I buy at 1 now. On the next day, I see that 1 minus 5, 5 minus 1 gives me 4. So my profit is 4. So current profit is 4. Then again I go 1 minus 3 or 3 minus 1 is 2. Then I get a 2 profit, but 4 is highest. So I'm not going to sell on this 3. Let's sell on 6. 1 minus 6 is 5. So I've got a higher profit. So I might sell on 6. But let's check 4 as well. So 1 minus 4 or 4 minus 1 is 3. So my maximum profit is if I buy on 1 and sell on 6. So that's why I have written 1 gives me 5 profit. Similarly, if I buy at 5, my maximum profit is 1 because I have to sell at 6. If I buy at 3, my maximum profit is 3 because I have to sell at 6. If I buy at 6, I don't get any profit because there is only one day after that which has 4. If I buy at 4, there are no days after that, so I get 0 profit. So maximum profit 5 if I buy at 1 and sell at 6. But we are not going to use this easy approach. What is this approach? O of n square. 2 loops. Just like previously I explained. Outer loop and inner loop. Simple thing everyone can do. That's why we are not going to do. This takes a lot of time because we are iterating again and again and again. Same thing. Redundant iterations I told you we are not going to do. So what is going to be the efficient solution? This is my array, a higher array I've taken.
Only update buy price. Now some rules I have written. Let's see the rules first. After that we are going to see the question. Let me drink some water. Only update the buy price if new price is lower. What does this mean? 7. Currently my buy price is 7. But I have got a lower buy price 2 over here. Then why am I going to buy at 7? I am going to update it to 2. I am going to buy at 2. I am not going to buy at 7. So only when I get a lesser value than my buy price, only then I will update my buy price with my lesser value. When do I sell it? Try to sell if my new price is greater than my buy price. Only if my new price is greater than my previous buy price, only then I'm going to sell. That means, let's say at 2, I have bought my stock. And then I see that 4 is there. 4 is my new price. 2 is my buy price. So I can sell, right? I will get a profit. I will get a profit of 2. 4 minus 2, I'll sell it. Trying to sell it, okay? Don't sell it final time. I'm trying to sell. So what will be my current profit? Today's price, that means 4, minus buy price, that means 2. That means gives me 2. Update the maximum profit whenever current profit increases. Current means current profit. Update my maximum profit when my current profit increases. What is my current profit right now? 4 minus 2. When will I update my profit? Next iteration I am going to get 5. What is 5 minus 2? 3. So the profit has increased. Profit previously was 2, but now it is 3. So I will change my date of selling to this date. I will sell at my price 5 and my profit would be 3. Okay. Now let's see the dry run. So as you see, like 1, 2, 3, these are not the prices. These are the iterations. Okay. First iteration, 7, 2, 4, 5, 1, 3, 6, 4 are the elements. Note it down somewhere so that I don't have to scroll again and again. Buy price is 7. I have bought my stock. Now there are 2 more variables, profit and maximum. I have bought my stock 7. I have not sold it, so I don't have any profit right now. My current profit, this profit is my current profit, and max is my maximum profit. Current profit is also 0. Maximum profit is also 0. Next day, I have encountered 2. 2 is less than 7. What was the first rule? Update my buy price is new price is lower. New price is lower, 2 less than 7. So now I will buy it at 2. I will not buy at 7. I have bought at 2, not sold it. So again, profit is 0, max is 0. Next, let me see. I have encountered a day price 4. Next price is 4. 4 is greater than 2. So I cannot buy at 4, but I can sell at 4, right? Because new price is greater than buy price. So my profit will be 4 minus 2, 2. What will be the maximum profit? Previous max was 0. So obviously 2 is greater than 0. So maximum profit now would be 2. Okay. Next value is 5. Let's come. Buy price still remains 2 because 2 is less than 5. And profit now gets updated. Because 5 is greater than 2. What was the new price greater than buy price? So 5 is greater than 2, new price and buy price. 5 minus 2 is 3. This is my current profit. Previous max profit was 2. 3 is greater than 2. So max profit also becomes 3. Okay. Now let's see the next variable. Next I have got my number as 1. This is my price of the stock. 1 is less than 2. So that means I will update my buy price. I will not buy at 2 anymore. I have got a lesser price. So I will buy at 1. I have not sold my stock yet. So my profit would be 0. And my maximum from previous iteration, my maximum is 3. Don't erase the maximum just because we have changed the buy price. Maximum till now is 3. So consider that 3 only, but no profit. Next, what we have got is 3 over here. 3 is greater than my 1. 3 is greater than my 1. So buy price will remain the same. Profit becomes 3 minus 1 because 3 is greater than 1. So profit is 2, but the maximum is 3, right? So we will not update the maximum. What is the next variable? 6. 6 and 4 are the next two. Okay, I'm not scrolling again. 6 is greater than 1, so I will not update my buy price. I'll buy at 1 only, but then sell it because 6 is greater than 1. 6 minus 1 gives me 5 as the current profit. Maximum was 3, so I will update it. My max is now 5. The next variable was 4, value was 4. 4 is greater than 1, so I will not buy at 1 only. Profit when I sell at 4 would be 4 minus 1, 3. 4 minus 1 is 3, I have not written. But the maximum will not increment because max was 5 and profit 3 is not greater than my 5 value. So ultimately my maximum value is 5, which is your answer. Now this is a very important algorithm of subarrays. This is cadence algorithm. In the first class itself, you have learned what? Sliding window, hash map, cadence algorithm. And I am pretty sure you have understood it because this is the simplest explanation I could have found. There is nothing simpler than this. What is the time complexity of it? O of n. Why? Because we are doing it in one pass, right? You saw it. I took elements one by one, right? So there is 8 elements and 8 iterations, right? So there is the O of n time complexity and space complexity is constant. We don't need any additional space. As I said, these variables don't matter. Don't go to an exam and say that the space for this variable is required, so this much space. No. This variable space don't matter. If you're taking a hash table, let's say, then it will become O of n. So space complexity of O of 1 over here. Let's see the code. There is one method. It is returning type integer. What is this integer? Maximum profit. It is accepting what? The prices of each day. The stock prices of each day, this array. First buy price would be my index 0 price as we discussed, right? First buy was 7. So I have taken buy prices 0 as my first buy price. And profit, that means my maximum profit right now is 0. This is my maximum profit. Okay. Now, you will not start the index from I equals to 0 because I equals to 0 is already tackled. And we know that the profit for this 0th index would be 0 and max would also be 0. That's why you will start from 1th index, first index, less than prices dot length. That means till the last index. If my price is less than my, okay, one thing guys, please listen to all the code explanations I am giving. Just because let's say you're coding in Python, you will not listen to Java, don't do that. Because the logic is the same, right? Only the syntax is different. And this is not the class to teach you syntax like from basics. Those are done. Programming lectures are like there. You can see those syntax. This is DSA class. DSA is very different from programming. That is what people think programming. Okay, that is DSA. No. DSA is all about logic. You are not going to learn syntaxes here. These explanations which I am giving, right, in writing, this is what DSA is, not this code. Okay. Okay. So if my price is less than buy price, which I have written over here. What did I write? Here. If my new price is greater than my buy price. Oh, sorry. If my buy price, if new price is lower. So if my new price is lower than my buy price, we'll update it. And if my new price is greater than my buy price, we'll sell it. That means calculate the profit. What is happening here? Prices of I is less than my buy price. What is prices? My current price. If it is less than my buy price, that means the buy price which I had allocated before. If this price is, my current price is less than my buy price, I will update my buy price because I have got a lesser value. Then why will I keep the previous value, right? After 7, there was 1. So that's why I'll update my buy price with 1. This loop will do that only. Only the buy price will be updated. Now we are calculating the profit. The current profit is my prices minus my buy price. That means my current price minus my previous buy price which was already there. So the current profit is calculated. Now I will calculate the maximum profit. This is the maximum profit variable. Math.max of current profit, comma profit. That means whichever value will be higher between my current profit and my maximum profit, that will be stored inside this profit. So this whole thing continues in my loop, and after that, after all this loop is done, one pass, single pass, I'm going to return my profit. C++ code also same thing. It will return an integer value and it accepts this array prices. I will declare my buy price as prices 0 as the value, and my profit I will initialize it with 0. This is maximum profit which you are going to return. Then start the loop from index 1 to my prices.size minus 1 last value. If my current price is less than my buy price, then update my buy price. Buy price equals to my prices I. Updating the buy price. Updating is done over here. If we don't need to update it, then we'll calculate the profit. Profit equals to my current price minus my buy price. You can see over here the same thing we are doing, right? Current price is 5, buy price is 2. That's why profit is 3. After we have calculated the profit, we are going to calculate the maximum profit, profit of max of current profit and profit. Whichever will be higher, that will be stored here. Where is this max method? This is a inbuilt method. You can use these things in Infosys, so don't worry. Their compiler is not like bad as TCS. Okay. And then return the profit. Fine. Similarly, for Python, we'll take the prices as the input. Buy price will be prices of 0, profit equals to 0. Start my for loop from I to the length of the, for 1 to length of the prices, from 1 to n minus 1 basically. Price is less than my buy price, then update my buy price. And if I have updated it, after that, or if I am not updated, current come out of my if block. Current will be price minus buy price, that is current price minus my buy price, and then update the profit as maximum profit as well. Between current profit and maximum profit, whichever will be higher will be stored inside my maximum. So if my current profit is higher than my maximum profit, max profit would be updated and it will be stored inside my profit. This whole for loop will continue, and after that will return the profit. Okay. Let's see in the chat. See, cadence algorithm is nothing but just the subarray, right? We were doing. This is subarray sum, right? What are we doing? Subarray is not sum. Subarrays we are taking, right? Here subarrays we are taking. First I have taken 7. Then I have compared 7. Then I have again updated 2. Then I have written the profit of 2. Here, like buy is 2 and profit is 5 minus 2 is 3. So that means 2 is over here, 5 is over here. So I'm taking a sub-array over here between 2 and 5. That is what is happening in cadence algorithm. Sum of sub-arrays or sum of subsequence. That is what cadence algorithm is. Simple. This is a simple implementation of cadence algorithm. Okay, what is the difference between two pointer and sliding window? See, two pointer and sliding window is one implementation of two pointer. Without two pointer, you cannot do sliding window. First pointer is left, second pointer is right. You are sliding the left and right to whether you want to increase the window or you want to decrease the window. Just after two pointer, I will be teaching you two pointer and sliding window. These topics I will be teaching you. So more problems we are going to solve using these things. Ma'am, the approach you used for two sum was two pointer, not sliding window. It was sliding window only because what am I doing? I am taking one window, right? Where did it go? Yeah, this is one window, right? First window is starting from 1 to 42. Then for this, I am again shifting to 23. Again, 23 is shifting to 16. This is sliding window only. What is the sliding window? This is not fixed size. This is a variable sized sliding window. Okay. Time complexity of hash map to provide resource. Time complexity for hash map is O of n. CGPA criteria, I am not sure. It is written somewhere, maybe in the application. These things I am not sure. I am only here to teach. Can you explain how to know about space complexity? See, here, right? Why is the space complexity O of n over here? Because we have taken a hash table, and the maximum number of entries I can put in this table is n, because the size of the array is n. It can exceed to n entries. So maximum time complexity we have written as O of n. Okay. So many doubts. Yes, if you want to return the best day and to buy and sell stock, then you need to return the array of days. How to do that? Using indexing. You will go back to the indexes, and just like we did in the previous problem, right? There was another problem where we searched in this array for our indexes. I had written, now look up 4 to 15 in original array. So you will just do a traversal and you will find the indexes and return the array elements. I am not sure if you can use AI in first level, but what's the use? Again, you'll have another exam, right? So it's better you learn. But you can use AI if you want, but I don't know. How do we know we have to apply cadence algo? Forget about cadence algo, forget the name. This is just a logic I explained you. Just keep the logic in the mind. Don't keep the name in the mind, okay? The moment you come to names, it becomes complex. Cadence, you don't know. But the explanation is clear, right? It's a very simple explanation. There are 3 variables. There is no algorithm. Forget the name now. Okay, I can see many chats with saying good explanation, so thank you. If array contains negative integer, can we use 2 pointers and sliding window? Yes, of course. There is nothing called negative positive. Here 2 pointer, the moment 2 pointer comes, there is nothing called negative positive. It depends on what kind of problem you have, right? If it permits you summing up one negative and positive element, then you will use a 2 pointer method. Okay, I cannot take so many doubts. I have to move to the next PDF, okay? Otherwise, I'll keep taking doubts and your class will be missed. Okay. So now we come to the prefix sum. Here I have taken one easy problem just to let you know what prefix sum is, and another difficult problem. As I said, right, in the previous PDF itself, right, the running sum, whenever I was telling, we can do using prefix sum. So that only here we are going to see. Water break. So what is the concept of prefix sum? Instead of recalculating the sum repeatedly, right, which we were doing previously, sum plus equals to x, continuously calculating the sum, we can store the cumulative sums in advance. That is the concept of prefix sum, storing the sums in advance. Now you don't need to do always the storing thing. You don't need to do this always. In some problems, you will see that storing the sum becomes easier for you to solve the problem if you store the sum. That's when you will apply prefix sum. We'll see what kind of problems those are. It is used for range sum queries and sub-array problems. What are these? We'll see. How to use a prefix array, how to build a prefix array. This is a simple array declaration. Let's say previously there was one array called ARR. There was one array called ARR which had some elements. So you will declare a similar array called prefix. Int prefix equals to new int ARR dot length of the same length. And store the prefix 0 as ARR of 0. Why? Because let's say this 2, 3, 5, right? Before 2, what are the elements present? No elements are present. So prefix sum of 2, there is nothing before 2. But if you want to calculate till 2, what is the method? Prefix of I equals to prefix of I minus 1 plus ARR of I. That means whatever sum is present before my ith value, that is the prefix sum of my ARR, and then the current value would be plus ARR of I. So that means plus 2. Before 2, what was the sum? 0. That's why I've stored 0 over there, plus my ARR of I. That gives me 2. Similarly, for the next element, I equals to 1, you will have this second element is 3, and the prefix sum was 2. Now you see I have already put 2 over here in my array, right? So I don't need to calculate the sum anymore. I can access this 2 from there. You'll see later on also I've drawn diagrams. Access this 2 from my array, I minus 1, plus my ARR of I, my current I, 3. 2 plus 3 gives me 5. Then for the fifth value, like 5 value, what would be my prefix array? Prefix of I gives me prefix of I minus 1 plus ARR of I. That means prefix of I minus 1 is 5. From here, this prefix array. And then ARR of 5. 5 plus 5 is 10. That's why there is 10. Okay. Range sum also, similar range sum query. In sum, prefix of R is, if my I is greater than 0, then prefix of I minus 1. If my I is greater than 0, then prefix of I minus 1 would be the answer. If it is not greater than 0, then 0 would be the answer. Okay. So it removes any extra left portion and gives the sum from L. Okay, this was L to R. So if my L is greater than 0, then prefix of L minus 1, else it is 0. So it gives the sum between L to R. This also we are going to see. Hold on. Everything is going to come. Deduces the time from O of n to O of 1. Using hash maps, how to do prefix? We'll declare a hash map of type integer. That means integer column 1, integer column 2. Put 0 and 1 in my hash map. This also we are going to see. Okay. Every type of things we are going to do in this class. Hopefully we can finish. Int sum equals to 0, count equals to 0. What are these? We are going to see. If for int num of ARR in my ARR, this is a for each loop. For each num in my ARR, that means for each value in my ARR, we will calculate the sum. That means for the first value, the sum would be the first value itself. Now we will search in the map. If my map dot contains sum minus k. That means if my map is already containing what is k, this is the target value. This is the target value, not written it, right? So you'll come to know what this is. Okay, let's remove this because this later on, right? This problem, this same thing is there. Same implementation is there. So let's not see this right now. You don't have the problem right now. So you'll not understand what k is. But basically, see, we'll search for sum minus k, and then if we find that, we'll do count of plus map dot get sum minus k. That means we're incrementing the count. We'll come to it. Okay. I know it's confusing. Leave it. Let's come to the first problem. Running sum, right? What is running sum? As we say, we go on calculating the sum. That is what running sum is. Given an array nums, we define a running sum of an array as sum of I equals to sum from 0 to I. What does this mean? From 0 to that ith index, whichever elements are present, add those. That is the running sum. So what would be my running sum of my whole array? For my last element, what would be my running sum? It will be the addition of all the elements in my array, right? So return the running sum of nums. That means we need to return the array. So 1, 2, 3, 4. What is the running sum of 1, 2, 3, 4? How many elements are present before 1? Nothing. So 0 plus 1 gives me 1. How many elements are present before 2? What is the running sum before 2? It is 1. So we don't need to calculate it again. 1 plus 2 gives me 3. That's why output is 3. Look over here in the explanation. Running sum for 3 would be already calculated in the previous one. See, 1 plus 2. I am telling already calculated because that's how we will solve using prefix method. Otherwise, it's just the two elements before it, 1 plus 2 plus its current element 3. So 1 plus 2 plus 3, 6 is my running sum of 3. For 4, 1 plus 2 plus 3 plus 4 is my running sum of 4, 10. Similarly, for this array also same thing will happen. I'm not explaining again because we'll see the explanation here. Running sum is sum till my current index. This is the brute force method. What is the brute force method? First running sum would be 1. Second running sum, follow the colors please. The second running sum would be 3. 1 plus 2, 3. Third running sum would be 6. 1 plus 2 plus 3, 6. Fourth running sum is 1, 2, 3, 4, 10. Fifth running sum 1 plus 2 plus 3 plus 4 plus 5, 50. Follow the colors. Why is it O of n square? Because we need two loops. One is the ith loop, second is the jth loop. The ith loop will be starting from 1. Jth loop has 2, 3, 4, 5. So we will take O of n square time complexity. But obviously we are better, so we are not going to take so much time. We want to impress the interviewer. How? What were we doing? Firstly, there were these elements, 1, then second element 1 plus 2, third element 1, 2, 3, fourth element 1, 2, 3, 4, fifth element 1, 2, 3, 4, 5. But let's see what the pattern is over here. When we are calculating the running sum for 2, we are doing 1 plus 2. But where is this 1 coming from? From my previous element? Yes. But we already have one prefix sum called 1 over here. We can use that prefix sum instead of going back to my previous element and having two nested loops, right? We don't need those nested loops. Whenever I'm calculating the running sum of 3, 1, 2, 3, 1 plus 2 plus 3. 1 plus 2 is already calculated in the previous iteration. See, 1 plus 2. That means 3. We already have the prefix sum, right? 3. So 3 plus 3 is 6. From here directly we can do. For 4 also 1, 2, 3 in the previous iteration we had already done. So from here we can retrieve it. Similarly for 5, 1, 2, 3, 4 we have already done in the previous iteration. We can retrieve it from my stored prefix array plus 5. So in the previous steps we have already calculated the prefix sum. So we don't need to calculate again. So since in previous step sum is already there, we can just do num of I equals to num of I plus num of I minus 1. What is num of I minus 1? My prefix sum. That is what we did over here, right? Whenever I was explaining you, right? Prefix of I equals to prefix of I minus 1 plus ARR of I. Same thing we are doing over here. Num of I equals to num of I plus num of I minus 1. Why? Let's say 5, right? What is num of I? 5. What is the prefix? What is num of I minus 1? Before that we have already calculated 1 plus 2 plus 3 plus 4. So that is num of I minus 1, 1 plus 2 plus 3 plus 4. Why I have written num? Because I don't want to create one extra space. I can do it in the single array only. How? We'll see. Very easy question. This question I have taken just to give you the idea what prefix sum is. Time complexity would be O of n because we are doing it in one pass. I prefer to do everything in one pass because that's easier to write. That's what matters. And we are not taking any extra space because in the same array we are doing. This method we had which was returning my array, integer array. We need to return a new array of prefix and it is accepting my array nums. Now, do I need the prefix sum for my first element? No, because the prefix sum for my first element is 0 and since I need to calculate the running sum, that means prefix plus my current element, it will be the same nums only. So I don't need to calculate my 0th value. So I don't need to change it basically. I am not taking any additional array. That's why I've started my loop from I equals to 1. If you take another additional array which you don't need to, then you have to start your array from I equals to 0. Okay. Now, I mean not I equals to 0. You have to put that in your new array. You have to put the first index as nums of 0. Because you cannot start from I equals to 0 because we are accessing nums of I minus 1 here. Your program would fail. For int I equals to 0, I less than nums dot length I plus plus, simple iteration. Nums plus equals to means what? Nums I equals to nums I plus nums of I minus 1, same thing which we wrote over here. And then this after this whole iteration will return the nums array. That means the prefix array, the array which we have updated. Similar thing happens for C++ as well. We return a vector, accept a vector, start this loop. Again nums of I equals to nums of I plus nums of I minus 1. 1 second. Nums of I equals to nums of I minus 1 and return the nums. That means after whole iteration, return the prefix array. Similarly for Python also, again in the method you accept the array, and for I in range, start the loop from 1 to my length minus 1. Obviously in Python you know it takes till minus 1, and nums of I equals to nums of I plus nums of I minus 1. This is how you write something plus something plus equals to. Okay, you can write like this also, that's not a problem, just it looks cleaner. Okay, and return the nums value. This is the Python code. So that was a simple code. We are not going to go much deeper into that. Let's come to the main subarray code over here. Given an array of integer nums and an integer k. That's why I said that I'm not going to explain that k thing there. See, what are these things? These things which I wrote, right? Prefix plus hash map, things like this. These are not the coding problems code. These are the concepts. So you see, right, this same concept would be used in our this problem. This same concept would be used here. That's why seeing the concepts is more important, because this same concept which you use in the subarray sum equals k, this same thing you will see in LeetCode and multiple other problems also. This same copy paste code you have to do. I have multiple times copy pasted a same solution in a different problem, and it has given me 99% beat solution or 100% beat solution, because the idea is the same. These are like algorithms only. Okay. So we have an integer array nums and an integer k. Return the total number of sub-arrays whose sum equals to k. What is a sub-array? Sub-array is a contiguous non-empty sequence of elements within an array. Contiguous means what? One after other, and it is non-empty. What does this mean? See, now I will not explain using this one. I am going to explain using 1, 2, 3. What is a subarray? 1, 2. This is a subarray. 2, 3. This is a subarray. 1 is a subarray. 2 is a subarray. 3 is a subarray. 1, 3 is not a subarray because it is not contiguous. It is not one after the other. Okay. Now, what is the question asking? There is a variable value k they have given, k equals to 2. I have to return how many sub-arrays are there inside my array, divisions of my array, how many are there, which return the sum 2. If you take this 0 and 1 index, right, 1, 1 gives me 2. If you take this 1 and 2 index, 1, 1, this also gives me 2. But I cannot take 0 and 2 index 1, 1 because this is not sub-array. So in a total, I have 2 sub-arrays which return the sum k. Sum 1 plus 1 is 2. Similarly, here if you see 1, 2, 3 is the array, k value is 3. If I take 0 and 1 index, that is 1, 2, 1 plus 2 is 3, fine. If I take 2, 3, it gives me 5, so I cannot take. If I take 1, 3, that is not even a sub-array, so I cannot take. But single 3 I can take. So I have taken 3, that is also gives me k value 3. So 2 sub-arrays are there, right? And non-empty it has to be. Now, what would be the brute force approach? Okay. Here 3 approaches I have given. That's why I am saying in one problem there would be 3 problems. I have taken, you can see, a bigger array to explain you, so that you can see multiple steps or what are the difficulties you can face while using the brute force approach, basically. Sorry. There is the subarray array 2, 3, minus 5, 5, minus 5, 1, 4. K value is given 5. In the brute force approach, what would you do? 2, 3, 2 plus 3 is giving me 5. Then again you will calculate what is this. So how are we using prefix sum here? 2 plus 3 is giving me 5, right? So I already have 5 over here. What if I calculated 2, 3 and minus 5, this whole thing together? So 5 minus 5 gives me 0. This 5 is already calculated. Prefix sum, right? I told you. 2 plus 3 is already calculated. So I'm not doing 2 plus 3 minus 5. I'm doing 5 minus 5. That gives me 0. So these 3 elements sum is calculated. Now let's come to this element. 2, 3, minus 5 and 5. Till this much 0 is there. So 0 plus 5 gives me 5. So like this continuously you have to do, and how much time does it take? O of n squared, right? Because inner loop and outer loop, nested loops, if you need I and j, then obviously n squared time complexity would be there. So this is just the first iteration, 5, 0, 5. This is just the first iteration. You have to do it n times. So that means it will take n squared time complexity. So instead of calculating the sum again and again, we can use the prefix sum and store it somewhere. That is the concept of prefix. Now let's see method 2. First method also you can do if you are unable to come to a better approach. That's why I'm showing you multiple approaches. Okay. Now this is the array. K equals to 5. My K value is 5 over here. What is my subarray 2 giving me as the sum? 2. What is my subarray 2, 3 giving me as the sum? 2 plus 3, 5. What is my subarray 2, 3, minus 5 giving me as the sum? 5 minus 5, 0. 2, 3 minus 5, 5. What is the sum? 0 plus 5, 5. 2, 3 minus 5, 5 minus 5. What is the sum? 5 minus 5, 0 again. Then from 2 to 1, what is the sum? 0 plus 1, 1. Then from 2 to 4, what is the sum? 1 plus 4, 5. So multiple subarrays are there. We can see 5, 5, 5. So many subarrays are there. But instead of calculating the prefix sum again and again, we store it inside another array or variable. Why do we need to calculate 2 plus 3 minus 5 minus 5 like this? Why do we need to put plus sign again and again in between these elements when we have these values already, right? So we have already these values. We can put them inside another array or variable. At every index, we will know what is the sum so far. So at index 5, we already know that the prefix sum is 0. Right? We already know the prefix sum is 0. At index minus 5, we already know the prefix sum is 5. That's how we are going to use. How? Sum of I. That's why I said this thing I'm going to explain later. Sum of I comma j. What does this mean? I'm going to tell you. Equals to prefix sum of j minus prefix sum of I minus 1. This is your array. 2, 3, minus 5, 5, minus 5, 1, 4. Sum of I minus j. See, this is I over here. This is j over here. Ith index has 5. Jth index has 1. What is sum of I minus j? Prefix sum of j. This is j. See, what is prefix sum? Yellow. I have underlined it with yellow. Till j, whatever sum is there, right, from 2 to j, whatever sum is there, deduct that sum, like from that sum, deduct prefix sum of I minus 1. So this is I over here, 5. Deduct whatever is there previous to this. So till j, you will calculate the running sum, that this is the running sum, okay? And prefix sum of I minus 1. From 5, 2 to minus 5, deduct it. What are you going to get? This pink one. From 5 to 1, whatever is the sum that you are going to get. This pink one is what is sum of I comma j. I have color coded everything. It will be easier for you to revise. So sum of I comma j, how do we get? This yellow line is the main big line, that is prefix j. From this prefix j, you will deduct prefix of I minus 1, this blue line. If you deduct this blue line from this yellow line, you will get this pink line, which is sum of I comma j from 5 to 1. Why do we need this? We'll see. Using this, we could get the better approach. So what will be the best approach? You see, right, this sum ij which we were doing, right, from 5 to 1. That means from sum ij, prefix of j minus prefix of I minus 1. This thing, if it is equal to k, what happens? That means it is a valid subarray, right? That's what the question was telling. What was the question telling? Return the total number of subarrays whose sum equals to k. So 5 and 1. 5 minus 5, 1. This is one subarray we have got, right? So if its sum is equals to k, this pink value is the sum. If it is equals to k, that means we have got our answer, one of the answers. We have got one of the valid subarrays. So the best approach would be, if my prefix sum of j minus prefix sum of I minus 1 is equal to k. Okay, that means it is a valid subarray. How do we do it using a hash table? As I said, right, we are going to do a better approach. Obviously, we are going to get a first slot for it. 5 to 1, only one slot we are going to get. But we need multiple slots like this. We need multiple subarrays like this. How to calculate that? We cannot do it in O of n square. We have to minimize it, optimize it using a hash table. Hash table, I already told you what a hash table is. So here in this hash table, we are taking column 1 as sum, that is the key, and column 2 as count. Okay. First, we are taking this first element 2. Before we take the first element, we have to initialize this hash table. Why? We don't always have to initialize it, but for this case, we have to initialize it because before 2, we don't have any sum. But still we have to write it because 0 prefix also we are going to use somewhere. You will see where, and 0 prefix is the one we are going to use the most in this problem. That is why I have taken this kind of input value. Sum is 0 and count is 1. I have cut it, but that doesn't mean that it is not there. Okay, that's why I cut it in a different color. First value would be 0 and 1 in the table. Nothing else is there in the table right now. Forget it. First value is 0 and 1. Because the prefix sum before 2 is 0 and it is occurring only once. Only once 0 is occurring. Okay. Now come to the first iteration. My sum is 2 now. See, first element is 2, so sum is 2 over here. Now, k value is 5. So 2 minus 5 is minus 3. Is it present in my hash table? No. Minus 3 is not present in my hash table. A similar kind of problem we did previously, right? 16, 0 we were putting in the hash table if not present. So I told you, right? One kind of concept if you learn, right, you will be able to do it in multiple problems you will be able to solve. So is it minus 3, is it present in my hash table? Right now, nothing is present in my hash table. Okay, only 0 and 1 is present. These values are also not present. No, it is not present in my hash table. If it is not present, we are going to put this 2, that is the value, sum value, 2 over here, and my count value is 1 because only once this has occurred till now. 2 has occurred only once. Hash map, we are updating the count, frequency of occurrence of my value. Now, let's come to the second variable. 2 plus 3. 3 is the second variable. Sum was 2 previously. Current sum, previous sum, whatever you want to say, prefix sum. 2 plus 3 equals to 5. Is my 5 present in my table? Oh, sorry. 5, k value is 5, okay? As I said, right, 0 we are going to use. That's why we need to add 0 in the table. Sum value is 5. 5 minus 5 is 0. Is 0 present in my table? Currently, my table contains 0, 1 and 2, 1. Nothing else is there, okay? 0 is present in my table. So what will I do? Cut this 1 and write 2 over here. That means my 0 has the value of 2 now. 0 is pointing to 2 now in my hash map. Okay. So another variable is also there. See, previously I had written total count as nothing, because there was nothing to write. Nothing was there in the table. Now I can see that I have updated. The moment you update something in the table, that moment you will update the total as well. Previously my total was 0. And now I am updating. That means cutting some value from the table and writing a new value. The moment you write a new value in the table, you will write the total as well. I have written my new value in my table and I have written 1 over here. 0 occurs only once in the map. That's why I have written 1. Okay. Now, sum of 5 previously was there, and then the next variable comes minus 5. 5 minus 5 gives me 0. Then k value was 5. 0 minus 5 is giving me minus 5. We are not going to search 0. 0, that means the sum minus my k value. The complement method we are using and searching in the table. Is minus 5 present in the table? No. If it is not present in the table, we are again going to update it from my table. So again we get 0 and update my 0 and write the value over there. And total value is 1 over here. Okay. Sum equals to 0 plus 5. The sum was 0. Next variable is 5 over here. 0 plus 5 is 5. K value is 5. 5 minus 5 is 0. Is 0 present in the table? Yes. Since 0 is present in the table, the total we will take from the table. 1 and 2. We are taking from the 2 value as the last value of 0, right? So take this 2 from the table and put 1 plus 2 equals to 3 in the total. Previous total was 1. We are taking this 2. That means whatever value was present in the 0 index, we are taking and putting it inside my total. 1 plus 2 is 3 from math. Okay. Now comes the next one. Sum previously was 5. Next element is minus 5. 5 minus 5 is 0. And then 0 minus 5. 5 by k. 0 minus 5 is minus 5. Again, search for minus 5 in my table. Is minus 5 there in my table? No. These values are not there in my table yet. Okay. So I am not updating anything. My total still remains 3 only. Sum value is 0. Next variable is 1. 0 plus 1 is 1. 1 minus 5, that means sum value minus k equals to 4. Minus 4, sorry. Is minus 4 present in the table? No. So what will we do? Nothing to do because 1 is also not present. So nothing to do. You are going to add 1 over here. Now 1 is not present. That means you are adding the first occurrence of 1 over here. 1 and the first occurrence of 1. That is why you have added 1 over here. Similarly, previously we got 5 somewhere, right? 5, 5, 5. Where did we get 5? Here we got 5, right? Sum of 0 plus 5. That's why we had added 5 over here in the table previously. Okay. Next comes the sum value was 1 and the last variable was 4. So 1 plus 4 is giving me 5. Again 5 minus 5, that k value is 5. So it is giving me 0. Is 0 present in the table? Yes. So you will take this 3 value from the table and add my total 3 plus 3 equals to 6. Total previously was 3 and current value right now at 0 is 3. That's why I'm adding 3 plus 3 equals to 6. So 6 is my answer. So we found 3 contiguous subarrays with total sum of 5. How? Total sum how? Because the moment I have got 5 and the complement of my k value and the sum value, if it's 0, that means I found my answer, right? So the occurrences of 0 will get added over here. That's why I said 0 is the most important one in this concept. Subarray concept, okay? So the first 0, 1 is when we don't take any elements into consideration. That's how we started. Okay, time complexity is O of n because hash map maximum entries can be of n only, and space complexity is also O of n because, time complexity is O of n because in one iteration only we are like in one pass in the array we are doing it. As you saw, one by one I have accessed the elements. There is no need for any inner loop. 1, 2, 3, 4, 5, 6, 7 like that I have written. That's why there is no need for any inner loop. So that's why O of n only is the time complexity, and space complexity you have taken a hash map. There can be maximum n entries. That's why the space complexity is O of n. Okay. Let's see the code quickly. There is one subarray method. It is returning int. Int means what? It is returning the maximum subarrays we can find. Okay. Maximum subarrays we can find. That is what it is returning. And it is accepting this array and k, the array which we were using, and k value it is accepting. We have declared the hash map for sum and count. The map contains integer type for sum and count. And as I said, right, the first 0, 1 is when we don't take any elements into consideration. When nothing is there, sum is 0. If there is no element in the array, sum is 0. And it is occurring only once, right? Only once the sum can be 0. So sum count, that is my map name, dot put 0, 1. We are putting 0 as this sum and count as 1, like this. You can visualize it like this. Prefix sum we are taking as 0, and the resultant sum we are going to see what it is as 0. Again a for each loop. For each value in my nums array, I am calculating the sum, my prefix sum. Prefix sum plus equals to num till this value, whatever would be the sum. First value is 2, right? So the prefix sum was 0. 0 plus 2 is 2. Now, after I've got that 2, I will search in my array, right? I have written over here that is it present? No. Then we have to put the 2 in the array if it's not present. So I'm searching if my sum count dot contains key. Key means this first column. If my sum count dot contains my key of presum minus k. What is presum? The prefix sum minus k. What is the prefix sum? 2. Minus k means what? 5. Is minus 3 there in my hash map? That's what we did, right? Is minus 3 present? No. Then put 2. So if my prefix sum minus k is present in my hash map, if it is present, then what we will do? We will add it in my result. That means the total which we are doing, total 3 plus 3 equals to 6. Since 0 was already present, so I took 0's 3 value and added in my total. So resultant plus equals to sum count dot get presum minus k. Get means what? This second column, whatever value will be there for that corresponding value. For 0, 3 was there. So I am going to get that value of 3 over here. Result equals to result plus 3. 3 plus 3, 6. My answer. That's how it is processing. If my hash map doesn't contain that presum minus k, that is the complement. If it doesn't contain the complement, I am going to put my current presum. Sum count dot put presum, comma, sum count dot get or default presum, comma 0 plus 1. What is this? Simple, if I have to say, if this presum is not present in my hash map, it will put 1 as my first entry. So let's say this 2, 1 we have put for the first time, right? So what did this line do? First of all, sum count put presum, put my 2 inside my hash map, but first sum dot get or default. That means search in my hash map if my 2 is already present. Let's say my 2 was already present, then it wouldn't have put 1 over here, it would have put 2 over here, just like we were doing for 0. First, it was searching for 0 in my hash map. Is my 0 present in the hash map? If no, then I will put 0, 1. But if my 0 is present in my hash map, then I will cut this 1. Instead of this 1, I will put 2 over here. Okay. So that's why plus 1. I am incrementing that value with 1. So that 0, 1 will be incremented to 0, 1 plus 1, 2. Right? Okay. And after this iteration is over, we are going to return our result. Okay. Now, int subarray, again for C++, same thing. We are going to return an integer. It is accepting one nums array and a k value. And we are declaring one map of named sum count having 2 columns of integer type key value pairs. First sum count, we are going to give 0 for 1. For 0th index, there is 1. I hope you understand. For my 0th index, I am giving 1 as my value. That is 0, 1 as my first entry. Presum is 0, resultant value is 0. And for each variable, each num value in my nums, I am calculating the presum first. Presum plus equals to num. Till my num, what is the sum? And if I can find presum minus k in my hash map before my hash map ends, sum count dot find presum minus k. If I can find presum minus k before my hash map ends, not equals to sum count dot end, then I will add my presum minus k, whatever value is present for that index. That means for 0, 3 was present, right? That I am adding in my resultant value. 3 plus 3, 6 is giving me over here as the final answer. But if that presum minus k is not present in my hash map, I am going to add presum in my hash map. How? In sum count presum index, I am going to do plus plus. So previously it was 0, it would be incremented to 1. If it was 1, it would be incremented to 2. And in that particular index, I am adding it. Okay. After the whole iteration, I am going to return the result. Same for Python. It is accepting my array and k value. Again, in the hash map, first of all, I have put 0, 1. This is how you write a hash map. Python is always easy. You have to write the least amount of syntax in Python. Okay. Presum is 0, resultant is 0. And for each value in my nums array, I am calculating the prefix sum. If my presum minus k is inside my sum count. If my pre-sum minus k is present in my sum count, I will increment the resultant. How? By searching whatever is present inside my pre-sum minus k, that value I want, not the pre-sum minus k, but whatever is present corresponding to pre-sum minus k. That means this value. For corresponding 2 value, I will get this 1. For corresponding 0, I will get 3. Okay, that I am adding over here. So finally, I will get 3 plus 3, 6. If it is not present, then what will I do? I'll do sum count of pre-sum. That means in my pre-sum index, I am going to put sum count dot get pre-sum comma 0 plus 1. Just like Java, if my value is already present in the table, I'll increment it. If my value is not present, I'll put the value and 1. Means what? See, sum count dot get pre-sum. That means search for pre-sum. Is my pre-sum present? Yes. If it is present, then whatever this pre-sum is returning, let's say 2 it is returning. 2 was my value. No, let's do like this. Yeah. For 0, 2, let's say. For 0, 2 it was returning. You will increment that 2 to 1 plus 1. But let's say this was the first iteration and for 5 value we had not written yet. Let's say I'm searching for 5. 5 nothing it is returning, right? So you will take the default value 0. Then 0 plus 1, 1. That is what you are going to put. This is same syntax as Java, okay? After this whole loop, just return the resultant. Okay, so 4 problems we saw in this session, and in these 4 problems, those were not 4 problems. Each problem had 3 explanations. So in a total, you learned 12 ways of doing. Okay, let's see the chat. If you can write those explanations properly, then it would be better. I have written using a writing pen and pad. You're saying, no, I have written using writing pen and pad only. But if I write right now, right, during taking the class, then it will take double time as of what it is taking. You will not be able to finish your syllabus. That's why I've written like this. I am putting extra efforts before the class. These PDFs, it is taking me a lot of time to make. Okay. So otherwise, students will complain later on that we want refund. We have not completed the syllabus. That's why I'm doing like this. It is for your own betterment. Okay. How nums of I minus 1 works? I minus 1 is whatever is ith index, right? It is previous to the ith index. That's how it is. I am not sure what you're asking. Okay. Okay, Sahil, I think you're a bit confused. 2 pointer, you're saying that it means pick any 2 from the array. Correct. And sliding window means pick a group of standing together sub-array or chunk in the array. Correct. What did I do over here? Where was that was previous PDF or what? You're absolutely correct what you said. 2 pointer means picking 2 elements. Sliding window means picking a chunk. What do you do in sliding window? You take pointers, right? Left and right. Left pointer, you move like this. Right pointer, you move like this. Just like binary search. Left pointer, you move. Right pointer, you move. What we are doing over here, we are moving the left pointer. We are moving the right pointer. But correct. You are correct that we are taking 2 values and summing them. We don't need the middle values. But what did I say? This is a window we are considering. That's what I said. That is very similar to the concept of sliding window. We are not considering the middle values because we are not using them. We are not using a sub-array. But this is the concept of sliding window, right? We are moving the window. This is a window we are considering from left to right. That is what I explained. What I wanted to say is once you learn 2-pointed approach, sliding window also you learn in that session itself. If I send you my CV, we are not doing resume review anymore. The mock interview classes are over for now. Will we cover advanced topics such as bitmask DP, digit DP, DP segment tree? Infosys asked me these in last test. Yes, we will be covering the advanced topics in the later days, because without arrays, how can you do DP? DP is array only. What is the, and trees is linked list only. Without these topics, how will you understand those things, right? What is the pattern for second round? How to understand when these concepts should be used? See, this will come by practice. You attend these sessions, just explanation was a bit fast. I understand, because we have a lot of things to cover, right? The session name is marathon session, right? These are marathon sessions, just like one shot videos. So we have to cover these things very fast. You will get the recordings, you will get the PPTs. Please go through them. You will be able to understand, because I am going from basic to advanced. These are basic only. These are not, like, obviously these are lead code problems, but I cannot teach you syntax here. We are not teaching syntax here. This is a DSA class, and I am again and again saying DSA is different from programming. DSA falls under programming, but programming is normal syntax. That is what programming is. They teach you Java one shot, C++ one shot, Python one shot, but they don't teach you DSA there. They'll teach you the basic concepts of it. Okay. These are DSA problems or problem solving concepts we are doing over here. Live recording session, when it will be shared, I don't know, but it will be shared. I hope after after maybe 1 hour or so, if the recording would be available. Usually that's when the recordings are available. PDF will be shared. Kritika, you were not able to see the screen. I'm not sure why. Everyone was able to see. So maybe some network issue from your side. You'll get the PDF and everything. I'm not sure why you were unable to see. Can we do I plus 1 instead of I minus 1? Which question you're saying? This question. Previous PPT, I think. Survey. This one only, right? This is the. Oh, sorry. Day 2 PPT. Yeah, this one you're seeing, right? Prefix sum, J and I minus 1. Is this one you're saying? Tomorrow topic would be, to see. Tomorrow's topic would be 2-pointer and sliding window. Okay, that is Saturday, tomorrow. Sunday topic would be hashing and greedy. So one thing I would say, like, solving the array problems is the most important, because all the other problems will be based on array problems only. DP graphs, trees, whatever you're saying, right? Array, linked list, stack queue, these are needed. Without these, DP graph trees won't be. PDF is looking to congest while showing the code. I'm not sure. It's clear only. Maybe since the screen is wide, that is why you're feeling like that. But that's why I've kept it wide so that you can see the whole thing. Okay. Okay. I have to go for another class, so I will take the doubts in the next class. Okay. What is the homework we should do after this class? Practice array problems. That's all. Just go through this PPT and then practice on LeetCode. That's what I will suggest to. LeetCode is your biggest supporter for Infosys because Infosys picks up direct questions from LeetCode. Before Infosys exam day, I did one video on YouTube. There was one problem for coin change and another one was for house robber. The same DP concept which I taught in that video, no, just the next day on 26th April for 2025 batch, the same DP concept, 2 problems came. Same concept. They didn't even change the pattern. Using the same concept, you will be able to do those problems. Just copy paste. Okay. So that's why I'm saying that LeetCode is your best friend because those problems were from LeetCode only. Okay, I'll take the next things next class. Okay, that was all for today's video, guys. The PPT, PDF, whatever you want, that will be shared to you. Recording will also be available. I know you are saying some people that you could not join or you joined late. You can see the recordings. It will be available till you have the course duration. Okay. Thank you, guys. You can leave the class now.